The benzene undergoes substitution reaction in spite of high degree of unsaturation. This behavior which is known as aromaticity. If you passed over the red hot iron tube at 873 Kelvin, you will get the benzene. So what is meant by volatile? Which means to say that when a liquid can easily get evaporated, such liquids are known as volatile liquids. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called hydrocarbons. Under that, we have discussed about the aromatic hydrocarbon and we have understood that how to name the aromatic hydrocarbon, and we have learned that what is the actual structure of the benzene, and we learned that resonance structure of the benzene, and also we have understood about the orbital structure of benzene. Today, let us move on to the next topic of this unit about the aromaticity. So, we are going to understand the aromaticity in the benzene ring, and we are going to calculate the aromaticity in the benzene ring as well as with the other compound by learning the Hakka Rule and the condition of aromaticity, method of preparation of benzene and physical properties of the benzene we are going to discuss in this session. So firstly, I'll go with the aromaticity. If I say it is aromaticity, we know that the benzene can easily undergo substitution reaction to form a substituted product. This explains the aromatic nature of the benzene. So for example, if you write the structure of benzene, that is C6H6. So there are 6 carbon will be there attached with the 6 hydrogen atom. Is it right? Yes. And it has been balanced by writing the alternative single bond and a double bond. Is it right? Suppose if you remove any one of the hydrogen and if you substitute it with the nitro, chloro or bromo or iodo anything, it undergo substitution reaction very easily and forms a substituted product. This nature of the benzene which is known as aromaticity. Which is known as what? Aromaticity. The benzene undergoes substitution reaction in spite of high degree of unsaturation. This behavior which is known as aromaticity. Okay? And aromatic characters of benzene can also be explained based on the resonance structure, based on orbital structure, and also the presence of 4n plus 2 pi electron. So this rule which is also known as Hakka Rule. So we will discuss what is the Hakka Rule in the next slide. So the Hakka Rule says that whenever there is a cyclic or planar or conjugated system is there which are containing the total number of 4n plus 2 pi electron which is delocalized, they possess a high degree of unsaturation, and this behavior in this aromatic compound will be observed. So how to calculate the 4n plus 2 rule in the benzene and other compounds? Let's see by taking the example of benzene ring. We know that in the benzene ring there are 6 carbon atom will be there and 6 hydrogen atom will be there. Is it right? Yes. And there is a 3 alternative single bond and double bond will be there. Is it right? Now, if I consider the rule, the 4n plus 2, how many benzene ring will be there? Only 1. So, I'll consider n value as 1. So, 4 into 1 plus 2, it is equal to 6. This indicates that there are 6 pi electrons will be there in the benzene ring and there are 3 double bond which is there. Okay. So there are 3 double bond, which is nothing but a 6 pi electron. Okay. 6 pi electron. Hence, benzene is aromatic in nature. You can take one more example for this. I'll go with the naphthalene now. This is the structure of naphthalene. If you apply the formula here, that is 4n plus 2 rule. Here, there are 2 benzene ring will be there. So, it is 4 into 2 plus 2. So, 4 2s are 8. 8 plus 2 is 10. So, there are 10 pi electrons will be there in the naphthalene, and this 10 electrons, which are nothing but a 5 alternative double bonds. Is it right? 1, 2, 3, 4 and 5. So, there are 10 pi electrons which are nothing but a 5 double bond. Hence, this is also aromatic in nature. This is how we can easily predict the aromaticity in the benzene containing compounds. Or you can say that they are nothing but a benzenoid which are showing aromatic in their characters. Next, we'll go for the condition of aromaticity. If you are observing the aromaticity in the benzenoid compound, what will be the condition then? The condition are as follows. The molecule must be cyclic in nature, which means to say that whatever the compound which is there, that must be cyclic in nature so that it shows the aromaticity. And next thing is, it must be planar and it must have a conjugated system. That means it must consist of what? 4n plus 2 rule, which are nothing but a presence of conjugated double bond in that particular compound. These 3 conditions are necessary to identify the aromaticity in the given compound. The first thing is, the compound must be cyclic, the compound must be planar, and it must choose the Hakka Rule. Okay, we'll see with the method of preparation of benzene now. So, how to prepare the benzene? There are 3 important methods will be there to prepare the benzene. I'll go with the first one, that is cyclic polymerization of ethine. Okay, so when you take the ethine and if you passed over the red hot iron tube at 873 Kelvin, you will get the benzene. You will get it what? Benzene. So, that is why I have called this process as cyclic polymerization of ethine. Okay. So, what is the structure of ethine? We know that there will be a triple bond between the 2 carbon atom and there is only 2 hydrogen atom will be there. If you pass through the red hot tube, you know, it forms what? Benzene ring, that is C6H6 will be formed. And the next method is decarboxylation of aromatic acids. So, what is meant by decarboxylation? The process of removal of carbon dioxide is known as decarboxylation. So, if you do the decarboxylation of aromatic acids, you will get the benzene ring. Sodium benzoate is heated with soda lime and decarboxylation takes place to form a benzene ring. How to write the sodium benzoate? We know that there is a benzene ring. Okay, if I say it is sodium benzoate, that is sodium in the sense there will be a carboxylic group where H is replaced with a sodium. Okay, this is a sodium benzoate. When it is treated with soda lime, that is a mixture of sodium hydroxide plus calcium oxide. The mixture of sodium hydroxide and calcium oxide, which is known as soda lime, if you heat it, you know, you will get the benzene ring with the eliminations of carbon dioxide in the form of sodium carbonate. Hence, The name is known as decarboxylation of aromatic acids. If you take the aromatic acids and if you do the decarboxylation, you will get the benzene ring. This is another way of preparing the benzene, and it is very important for the examination point of view. And next thing is from the phenol. So how to recall the structure of phenol? Always write a benzene ring and write OH. So the phenol is reduced to benzene by passing the vapors over the heated zinc dust. So first I'll take the phenol, which is allowed to react with zinc dust. What will happen? This only the O will combine with the Zn and forms a zinc oxide, whereas the H will be remains as such, and we know that each carbon atom will having one hydrogen and forms a benzene ring. So this is another way for preparing the benzene ring by using phenol. So hope you are understood with the three methods. The first one is from ethyl and from decarboxylation of aromatic acids, then by using phenol, how to prepare the benzene. Any two you must remember. And next thing is physical properties of benzene. So what are the physical properties of benzene? We'll see now. Benzene is a colorless and volatile liquid. So what is meant by volatile? Which means to say that when a liquid can easily get evaporated, such liquids are known as volatile liquids. Okay? Its boiling point will be 80 degree and freezing point will be around 5.5 degree, and it has a characteristic odor. We have already learned that all this aromatic compound, they give very good smell, hence it is known as aromatic. They give very pleasant odor. Okay? And it is highly inflammable and burns with sooty flame. If you burn the benzene with the flame, it burns with a sooty flame. What does it mean? Any substances burns with the red as well as with the unburned carbon atom, that is known as sooty flame. You would have seen with your home, when you switch on the gas, if you put the new vessel on the gas stove, you would have seen it, the entire vessels will become very black at the end. Is it right? This indicates that the aromatic hydrocarbon, when it is burnt, it produces the unburned carbon atom in the form of the sooty flame. Okay? And it is lighter than water and having a specific gravity around 20 degrees Celsius, and it is around 0.87888 gram per cc. And it is immiscible with the water but miscible with organic solvent. So we all know that aromatic hydrocarbons are insoluble in water, but it will be soluble in organic solvents like ether, alcohol, etc. And remember, we can use this benzene as a very good solvent, especially for the fat, resins, rubber, etc. because it will be dissolved in it. And it is a non-polar compound having a dipole moment 0. And it has extremely poisonous substances, and inhalation of vapors or absorption through the skin has a toxic effect. This is very, very important. When we are dealing with the benzene, we must be very careful because it's a very poisonous substances. It can easily attach to the skin. When we inhale the vapors, it will cause us a serious health issues. So this is all about the physical properties of the benzene. In the next session, we are going to discuss with the last topic, that is chemical properties of the benzene also. We are going to discuss in the next session. In this session, I have covered the preparation, physical property as well as with the aromaticity. Have a look on it and try to work hard, and we'll meet you in the next session. Till that, take care, be safe. Thank you.